So let's go ahead and let's do an example of a substitution problem. And what I want to solve is we're going to solve dy dx is equal to y over x plus the square root of xy. And there's lots of substitutions that we can try. I think the most natural one to try would be u is xy. And it turns out that that's absolutely the right thing to do first. It just happens not to work. We could try u is maybe square root of y, because then you could recognize the top is u squared, and then you have a square root of y in the denominator. Also very reasonable, turns out not to work. And the right thing to do is to take the top and top and bottom, numerator, denominator, and divide by x. So what I'm going to do is I'm going to multiply by 1 over x. This is not obvious that this is the first thing to do. And in fact, I'm not a huge fan of substitution problems on exams. The reason is that I feel like it's too dependent on a single trick. Like, this is not an obvious step. This is not something that I would expect people to know to do in order to solve these equations. So because of that, I will give you a substitution problem that'll probably be like the first one, if I give you one at all. So I will probably help in some way. Either it'll be an obvious substitution, or I'll kind of guide you along and give you a hint about what the substitution is. Anyway, so if we multiply by 1 over x, then our differential equation that we're going to get is going to be y over x divided by 1 plus the square root of y over x. Okay, and so y over x divided by 1 plus the square root of y over x leads us to a guess that u should be y over x. And that turns out to be the right substitution. If we solve this for y, we get u is xy. And then we can find dy dx, and that's going to be the partial of ux with respect to x. So that's going to be u, plus the partial derivative of y with respect to, is the partial derivative of ux with respect to u times du dx. Okay, and so that's going to be our dy dx. And now let's see what happens here. We're going to end up with, u plus x times du dx is equal to u over 1 plus square root of u. Okay, so 1 plus square root of u. And then what we could do is we could subtract u from both sides. So we're going to subtract u from both sides. Oops, that should be a u. And now at this point, we could combine everything, which we might as well do. Let me just write this as a single fraction here. This is going to be u, and then minus u to the 3/2, just combining the fractions there. I'll let you work that out on your own. And now this is separable. And so this is now going to become, let's see, we're going to have the u's cancel. We're going to have 1 plus u to the 1/2 over negative u to the 3/2 du. That's going to be equal to 1 over x dx. And then we're almost there. This is going to be negative u to the negative 3/2 minus u to the negative 1 du. And that's going to be equal to 1 over x dx. And then let's see, if we integrate this, we're going to end up with 2u to the negative 1/2. Let's see, minus the natural log of u. You can put absolute values there if you want, equals the natural log of x plus c. And then there's no way to actually isolate u on the left side. So we're just kind of stuck with what we're stuck with. But what we can do is we can go back, we can look at our substitution. U is y over x. And so this tells us that 2 times y over x to the negative 1/2 minus the natural log of y over x equals natural log of x plus c will be our solution. And you can simplify this a little bit if you'd like to. So for example, you could write this as 2 square root of x over y, because you get it to the negative 1/2, so you take square root and you flip it. And then this is minus the natural log of y minus a negative natural log of x equals the natural log of x plus c, and then those cancel. And so you could write this, and there's other ways that you can simplify it if you'd like. You can try and get all the y's on one side, all the x's on the other, but you're never going to be able to solve for y anyway, so that doesn't really help. So you're going to end up with 2 square root of x over y minus the natural log of y equals c. Okay, and so that's going to be the series of curves. They're not quite functions, but that'll be the series of curves that'll solve a differential equation. Okay, and so that's how that'll work.